All right, calculus, here are your answers for the worksheet and how to work them out. So number 4, 5, and 6, here are the answers you should have got, and we went over those in class, so you can look online for the notes there. For number 7, the information that we know is that, not number 7, number 10, excuse me. The information that we know is the volume is s cubed for a cube, and that our volume is changing at a rate of 18 centimeters cubed per second, and that our side is 2. So they want us to find s prime at that time. So what we do is we find the derivative by moving the 3 in front, dropping 1 from the exponent, and taking it times s prime. What you do from there is you plug in your values. So we have 18 equals 3 times 2 squared times s prime. To solve for s, I'm going to simplify the right side, and I get 12 times s prime. So I divide by 12, and I get 18 over 12, or 3 over 2 centimeters per second for my s prime. For number 11, my volume of a tank they give me is pi r cubed. They tell me that the volume is changing at 15 cubic feet per minute. They want to know what the radius is changing at when our radius is 3. So you only have 2 letters, find the derivative. So we get 3 pi r squared times r prime. We put in v, 15. We put in r, we get 3 squared times r prime, we don't know. From there, you simplify, so you got 15 equals 27 pi. Divide by 27 pi, and you have 15 over 27 pi. Both of those are divisible by 3, so you get 5 over 9 pi. Feet per minute. And that is r prime. For number 12, they give us the volume is 2 pi r cubed. Our radius is changing this time, not our volume, and they want to know what our volume is changing at when our radius is 3. Only 2 letters again, find the derivative. So 6 pi r squared times r prime. V prime we don't know. R is 3, and r prime is 3 over 2. So we end up with, on the right side, 81 pi feet cubed, since it's volume, per minute. Number 13, we have 4/3 pi r cubed because it is a sphere and it's talking volume. We have our radius is increasing at a rate of 1 divided by pi inches per second. They want to know what our volume is increasing by, and our radius is 1. So we only have 2 letters. Find the derivative. You get 4 pi r squared times r prime. We don't know our volume rate, but we do know our radius is 1, and our radius is changing at 1 divided by pi inches per second. So if I simplify this, your pi's would cancel out, and you would end with just 4. And since this is volume, inches cubed per second. Number 14, we're also dealing with a spherical balloon. So we have the same equation for volume. This time they give us what our volume is changing at. They want us to find the rate of our radius when our radius is 3. So find the derivative. We get the same thing we got on the last one for our derivative. We plug in our volume this time. We plug in our radius of 3, and we do not have r prime. So we simplify the right side. 3 squared is 9, times 4 is 36 pi. We divide by 36 pi, and we get 28 over 36 pi. Both of those are divisible by 4, so you get 7 over 9 pi. And this is a radius, so it's only feet per minute. So that is what our radius is changing at. For number 20, they're talking about a square. So our area is s squared. They're saying our side is changing at 2 feet per minute, and our side is 7. They want to know what the area is changing by. derivative, since there's only 2 letters, and, ooh, I messed up there. It's 2s times s prime. So area is, we don't know. The side is 7, and our side is changing by 2 feet per minute. So 2 times 7 times 2 is 28 feet squared per minute, since it is the area. That's why it's feet squared. For 21, we have a sphere again, so 4/3 pi r cubed. You should have that memorized by now. Our volume is changing at a rate of 16 cubic feet per minute. They want to know what the radius is changing at when our radius is 2. Do the derivative. You should have that one memorized for our sphere, since we've done it numerous times. But if you don't, you can still do it on your own. The volume is changing at 16 cubic feet per minute. Our radius is 2. We don't know what our radius is changing at. Simplify the right side and you get 16 pi times r prime. Divide by 16 pi and you get 1 over pi. Oh, this is radius, so it's just feet per minute. All right, 22 is also dealing with a sphere. Same volume formula. This time our V prime is 12 cubic feet per minute. And they want to know what R prime is when R is 3. Do the derivative again. And we get 4 pi r squared times r prime. This time we know our volume of 12. We do not know our r prime, but we know our radius. So we can simplify the right side. 3 squared is 9 times 4 is 36 pi times r prime equals 12. Divide by 36. 12 over 36 is 1/3. So you got 1/3 pi equals r prime, and we would label that as feet per minute. '24 is a little bit harder. It was the extra credit from your homework last time. It is talking about a ladder leaning against a wall. When a ladder leans against a wall, it makes a right triangle with the bottom. So I'm going to label this side C, this side A, and this side B. And that's how I'm getting the a squared plus b squared equals c squared. We know that C, our hypotenuse, will always be 5 because that is what the length of our ladder. Our ladder length is not changing. What is changing are these side lengths when we move the ladder down. So they tell us and the base of the ladder is moving away at 0.4 meters per second. If you labeled your base as B, you would call it B prime. They also they want to know what B prime is, so what the height of the ladder is changing at as the ladder goes out when our base is 3. So if our base is 3 and our hypotenuse is 6, we can find that B value in our right triangle by using the Pythagorean theorem. So we have 5 squared minus 3 squared equals B squared. So you have 16 equals B squared. So B will end up being 4 in our problem at that specific point. We cannot plug in the 3 and the 4 yet because we have not taken the derivative. The thing that we can plug in to the a squared plus b squared equals c squared is the 5 because it's always going to be 5. The ladder is not changing. So we have a squared plus b squared equals 5 squared. So from here, you can do the derivative because you only have 2 letters, a and b. The derivative of a squared is 2a times a prime. Derivative of b squared is 2b times b prime. Derivative of 5 squared, or 25, is 0. So now we have an a value. We have an a prime value. We have a b value. We do not have a b prime value. And that all equals 0. Sorry, I had to move that over there. So 2 times 3 times 0.4 is 2.4 plus 8 times b prime equals 0. So if you subtract 2.4, you got negative 2.4 equals 8 times b prime. Divide by 8 and you get negative 0.3 equals b prime. which to me makes sense that it's negative since your ladder is moving down. So that rate is being negative, and that is meters per second. The trick on this one is that you had to find the b value so that you could get rid of letters. All right, 27 is dealing with the area of a circle. So we have pi r squared. The area is changing at -2 centimeters squared per minute. I chose -2 since it says it's decreasing. They want to know what r prime is when r is 4. So if we find the derivative of a, we get 2 pi r times r prime. A prime is -2. R is 4. We want to solve for r prime. So we got -2 equals 8 pi times r prime. Divide by 8 pi, and you get -1 over 4 pi centimeters per minute. That is what your radius is changing by, so none of the answers up above worked. For 29, we have a equals pi r squared. We have our radius is changing at 2 feet per minute. We want to know what the area is changing by if our radius is 7. Again, do your derivative. Plug in your area. Oh wait, we don't know that one, our derivative of our area. We do know our radius, and we do know our r prime. So simplify the right side. 2 times 7 times 2 is 28 pi, since it's area, feet squared per minute. And that is the answers to your worksheet. Have a great Friday.